Okay, so now we are talking about nodes and linked lists, and generally, they are ways we can do lists. Okay, so unsurprisingly, they're both ways we can do lists. Okay, one way we know how to do a list is an array. Okay, an array is this situation. Okay. And now we have this idea of a linked list. And a linked list is a train car of nodes. Okay? And we don't know what happens here or here. So like if I have an array of 4, 9, 2, 3, 6, 4, okay, I can similarly have a linked list where the data here is 4, and then its link references another node whose data is 9, and its link references another node whose data is 2, etc., etc. Okay? So, we could also, there's two ways we can do a list, and one way is this array way, and one way is this linked list way. Okay? And both are perfectly fine ways to list numbers, for example, or things. We can say, we're going to make them more general and say things, but right now you can just assume integers, just so we can concentrate on how this stuff is actually structured. So the array is a data structure. It structures data like this. And a linked list is a data structure. It structures data like that. Okay? Let's get even more into the weeds here. An array, what an array does, an array is an object, even if it is a primitive. So like int x equals new int three or whatever, okay, means that x is somewhere up here and it's referencing 3 variables on the heap, okay? And so x sub 0 will get you the first box, x sub 1 will get you the second box, and x sub 2 will get you the third box. And if you just system.out.print x, it'll give you the memory location of this first box. Okay? Actually, what x sub 0 is saying go to the memory location where this whole thing starts. And x sub 1 is saying go to the memory location where this whole thing starts and then give me an offset of 1 integer. So I get this one. Okay, and x sub 2 similarly is like go to the beginning and then jump down 2 integers so I could get this one. Okay, so that's all the array's doing. This is saying give me an offset. Don't give me the first box, give me an offset from this first box, the 0th box, so I can get a different integer. All right, and that's how we're able to represent a bunch of values in an array. Okay, which is just a list, right? Right now we can think of it as just a list. And we'll talk about what is a list in a second. You know what a list is, but we'll talk about it in terms of computer programming. Okay, now a linked list here it's doing stuff like this. Okay, so I have and we don't know how it starts or ends yet. I haven't told you that. But, we've got this one here, and then it's got a link to another. So these are each nodes, right? And we've got this node here, and it's got a link to another one, and we've got this node here, and it's got a link to whatever, okay? Now, where the difference between these two things in terms of memory are that arrays are contiguous in memory, meaning they are so contiguous, right? Or continuous, right? So when you contiguous and continuous, you can just think of they're together in memory, right? All these blocks are together in memory. The linked list, on the other hand, is made up of nodes, and these nodes, okay, could be anywhere in memory. All right, and so when we talk about Y lists, you begin to think about, well, what's more efficient in memory? Okay, it's hard to say, but a linked list, an array takes up a certain amount of memory. You have to have that contiguous block. So if you think of back in the day when we didn't have maybe as much memory as we do now in different systems, if I have an array of 100 values, I might have 100 values in memory. They might not all be together. And so now suddenly there's some sort of thing that has to happen in the operating system management to get me and 100 values together, 100 integer values together. A linked list, on the other hand, if I had enough to hold 100 integer values, even if they're not together, it doesn't matter. I can just point them, I can reference them wherever I want. So I could say, go to this next spot that's open after this spot, and go to this other spot that's open. So I can do that forever. Okay? Another interesting thing. If I wanted to resize this array, okay, what do I have to do? Well, I have to make a new array. Then I have to copy the values over. So I'm going to call this A, my array A. I have to copy these values over. And then I have to, and we can call this temp, okay? And then I have to do something like A equals temp, right? And what that'll do is A references this in memory, right? A references this array in memory, and temp T references this array in memory, and saying A equals T will now have A reference the same array in memory as T, okay? And this will be garbage collected, and A will now look like A, and then temp will just not use it. It'll drop out of scope at some time. And then A will look like it got a bigger array, okay? Now, we're going to go into this, and we will go into this in question form below. But you can think about what the big O is for doing this, right? We have to create a new array and then copy each thing over, okay? Let's say we wanted to increase the list of a linked list, okay? And we knew where it began or end. Let's say we knew where it began, and I haven't talked about it yet. How would we increase the size of this list when we knew where it began, right? So, 492, whatever, right? And if we know where it begins and someone says, oh, I want to insert 9 here or 100, you could just insert it here and point it over. So you can insert 100 down here, and now 100 is going to 4, 4 is going to 9, 9 is going to 2, and we're copacetic, okay? Importantly, there's no notion of a hard number of spaces in a linked list. You're just adding another train car, right? So in an array, there's an idea of I have this much memory and I'm going to run out of this much memory, so I can just make another array with more memory, and I have to copy the values over, and it looks like my array's gotten resized, but there's no real way to resize an array. I mean, there is. This is it, right? We're going to create we're really creating a new array and then copying the values over. Okay. And over here, what's going on is there's no notion of a hard cap on the number of nodes we can keep on sticking in here. Um, we just keep on adding train cars of nodes, and that'll increase the size of our linked list. So if suddenly someone wants to add 300 values, we could do that just right off the bat. Okay. In the array world, we might have to resize, and then if we hit that limit, resize again. Okay. And you can think about what the big O is of inserting here if we know exactly where we are. Actually, let's hold on to that because let's talk about actual cool linked list stuff. Okay, so now we're gonna get into the weeds of the linked list. But hopefully this kind of makes sense. This probably helps you with the why a little bit. So why would someone ever try to do a linked list? Well, it's a different way to represent a list. We know an array and we know a list. It has some advantages. One of the big advantages is that there's some sort of easy amount of effort to resize a linked list. Okay, and another advantage is that the memory doesn't have to be contiguous. Okay, there's actually some disadvantages too. We'll talk about that 2 videos from now. Next video, we are going into the weeds of the linked list. See you then.